In this video, I will provide some basics using RStudio for statistical analysis. In this specific dataset, we are using preloaded data in the software to carry out analysis and interpretation of output. Let's get started. In RStudio, which you would have previously downloaded, you would notice that there are various windows. The functionality is as follows. The top left is a window devoted to R scripts. Inside this window, you will be able to type R code and also comments, which you will subsequently run to perform your analyses. The top right-hand window provides the various variables in the environment and gives you history of the code that was previously run, as well as any specific connections. And of course, there are various tutorials for different packages that you can use within the software. The bottom right-hand window gives us an overview of the different files we have opened. Plots we have visualized, packages we have used, help and resources, a viewer when we are able to actually incorporate graphs and we would like to download them in different formats, and of course presentation, which will also follow. One of the most essential windows would be the bottom left-hand window, which is the R console window. For users who would have previously downloaded R, the base software, this window looks similar to the original window where the code is run and the output will be viewed. When you first open RStudio, you will see a blank document, an untitled R script, where you are able to type in whatever specific variables you have and be able to run that code. So for instance, if we assign A to the value of 2, we can highlight it and click run. And in the console window, we can see that it has captured that value. And if I were to put A again and run that line by highlighting and clicking run, I will be able to see the output shows me that 2 has been assigned to the variable A. Now let's jump to the pre-written code for the purpose of this tutorial. R includes preloaded example datasets for illustrative purposes. So in this example, we load the dataset called attitude, and in this particular set of variables, we would notice that we are able to harness different packages. Some of them are listed here. Now, before you run your analysis on the attitude dataset, which contains 30 observations of 7 psychological variables, you would have to install packages that would allow for you to obtain various graphs and perform different types of analyses, including a psych package, which we list as install.packages psych in quotes, dependencies equal true, so we can run the different parts of that package. We also have various libraries and requirements or loading of built-in packages that come with this particular package, as well as others. So we will load the psych package, the psych tools package from the library, and we will also use the built-in stats package and graphics package. Now, in terms of the dataset, if you would like to get more information about this attitude dataset, you can feel free to run the code attitude, and you'll be able to obtain full documentation. So first off, I will run the code for the various packages. You would notice that in certain versions of R and RStudio, they will ask you to install some of the packages or update them. In the meantime, also note that there are some comments in green which are preceded by a hashtag. And in this particular case, it gives us the chance to give an overview of the specific analysis or explanation of what is coming. As you can see, it ensures that the code looks neat and it's reproducible, and anyone who has their hands in the coding can understand what it's doing. So as you could see on the console window, the package has already installed. It said it has loaded the packages and the libraries. So we go to the next chunk of code. Now, in certain areas, I will run these lines together, but for the purposes of understanding, I will first start off by running them one by one. So if you would like to understand what's in the attitude dataset, as I mentioned, you can type $attitude. You would see it come up in the window because it's pre-installed. And once you run this line, on the bottom right-hand window, it automatically tells you in the help what this dataset is about. It's from a survey of clerical employees in a large organization, and the data is aggregated from questionnaires of approximately 35 employees for each of 30 randomly selected departments. The numbers give the percentage of proportions of favorable responses to seven questions in each department. As you could see, the variables are listed here. Now, let's return to the main script window. If you would like to access the actual data set to see what it looks like, you can type data attitude, run this code, and in here, you will be able to access the specific data set. Now, if you want to see what it looks like, at least the first 6 rows, you can type head attitude and run, and you can see in the console window, it gives you the first 6 rows of the data set in terms of those variables of interest. The dimension, in brackets attitude, gives us the dimension of the rows and the columns, the total data set. So we see that it's 30 rows and 7 columns. Then we can run names attitude, and it gives us all of the column headings or the variable names in the data set. Now, due to the nature of our programming and the coding used, we can rename some of the variables from the format it originally comes in. For instance, if I wanted to access the complaints column from this attitude dataset, I would have had to use a $sign between the words attitude and complaints. This is because this is an object within the larger data set that we need to call on. Of course, I will spare you the details of the computer science aspects behind this. For your purposes, what you need to understand is we actually have the mechanisms to rename this into an easier format. So even though we think that we want to access complaints, it's usually that we are accessing complaints via the attitude dataset, which looks like this. However, to easily use this variable, we can rename it. So I will run this code to rename complaints, and I will also rename rating as well. So we don't have to keep typing the longer attribute of the words. So let's jump into some basic descriptive statistics. We would like to look at the mean of the complaints variable, the standard deviation, and we could also look at a summary of all the descriptive statistics for all the variables. So let's run these codes. As you could see, the mean of the complaints variable is 66.6. The standard deviation is 13.31. And the summary attitude variable gives us the actual list of minimum, maximum, median, quartiles, etc. for all the different variables within the data set. Now, you probably want to think about having some visualizations or plots. A simple plot would be as follows. Plot complaints, rating. So we can get a scatter plot of the complaints and rating variable. As you could see, when we run this code, we can actually get a scatter plot of the two and see the spread of the data. As it looks here in the observations, it seems to be a positive trend for the change in complaints and ratings in this survey. If you would like to include other aspects, for instance, axes, titles, maybe change the color of the scatter plot, points, maybe include a title, you can run the code and recall a name which is different from plot, maybe plot 1, as follows. Notice it updates the plot with the title ratings, which is versus complaints, and includes those axis titles and blue dots for ease and aesthetics. Now, for all the variables, you may want to quickly look at a scatter plot in one specific diagram. So we can use the pairs function, as we call it, and pairs can take the data set, comma, and a title. So in terms of this data set, pairs attitude will give us a correlation matrix, and it has the scatter plot of each of the variables. Now, it may be difficult to see some of these, so you may want to actually plot some of them separately. However, it gives us a very nice indication of the way the variables are related to each other and the spread of the data as we go through pairs of variables within this data set. On to simple statistical models. Let's look at linear regression. Linear regression uses the function LM, which represents linear model. It takes the dependent variable and then includes an independent variable, or if we go to multiple linear regression, more than one independent variables. So let's first start with simple linear regression. If we look at rating, and then we have complaints where rating is Y, the dependent variable, and complaints is our independent variable. Let us run this code. And you can see that it gives us the same scatter plot with the line of best fit, or the regression line, through the points using the AB line function. However, you may probably want to look into the actual regression coefficients based on this line, as well as p-values for significance. We can then run the code summary of that regression model. And within the console window, you would notice you have the various coefficients for the regression model. And you have certain significance in terms of the variables within the model, as well as the overall model significance. So let's take a further look. In this model, we see that the intercept is 14.38 approximately, and the coefficient of the complaints variable is 0.75. When looking at the line of best fit, it tells us that the line cuts the y-axis at 14.38, and we can think of the gradient of the line, which is actually the coefficient of the complaints, or the x variable, as 0.75. This is a positive correlation between complaints and rating. And it's a moderate correlation because it's 0.7, which is fairly close to 1. Now, if you want to think about if complaints is significant in the model when it comes to ratings, you have to look at the p-values. So we look at the last column of this table. Now, we can ignore the p-value for the intercept since this is not of significance for us, but we can look at the p-value for the complaints variable. In this case, it is 1.9 by 10 to the minus 8, which is actually very, very close to 0, which means that this value of p, represented by the probability of the modulus of t, which is using the t value to find the p value, This is less than 0.05. Therefore, complaints is significant in this model. So if we perform the hypothesis test for regression, we would notice that complaints is significant. We could also find the R squared, which is called the multiple R squared value, where R squared is our coefficient of determination, which is the square of the correlation coefficient, the strength of the linear relationship between complaints and rating. Now, the multiple R squared, or the coefficient of determination, gives us an idea of what percentage of variation in this model is attributed to the independent variable complaints. Therefore, 0.68 means that 68% of the variation in this model is attributed to the complaints variable. The rest of the variation, which is about 32%, is not attributed to complaints, and we may want to investigate if there are other variables that are contributing to a significant difference in this particular model. We can also look at the overall p-value of the model, which incidentally in this case is the same as that of the complaints variable, since it's the only variable in the model right now. And this is also less than 0.05, which means that the entire model, or the overall model, is significant. You can also find the coefficients of regression separately by using the coefficients function. And I will run that code to show you that it gives you the intercept and the complaints values separately as we had before. You may also want to think about multiple regression, or multiple linear regression rather, where you have the dependent variable, which is rating in this case, versus more than one independent variables. For an example, I will include the privileges variable with the complaints variable. And let's run that and see what we get. As you could see in the console window, when we add the privileges variable to the model, we can see here now that we have more than one set of estimates or coefficients. We have the complaints variable coefficient is 0.78. The privileges variable is minus 0.05. We also have attributes in terms of the p-values for each. Now, before we move on, we must remember that these estimates are very important for that linear model of type y is equal to the intercept plus the coefficient by the complaints variable plus the coefficient of privileges by the privileges variable. What this means is when we look at the coefficients, we get a context as to how y changes with the change or 1 unit change in this variable. So if the complaints variable changes by 1 unit, we get a 0.78 change in the ratings. If the privileges variable changes, we get a minus 0.05 change in the ratings. So it gives us a context of how the increase or decrease happens within the model, so we can understand how the variables impact the model. Now, if you look at the p-values, you can see that the complaints variable is still less than 0.05, which means it's still significant. However, the privileges variable is not significant in this model since it's greater than 0.05. We can also see that the multiple R-squared value is 0.68, so it has not changed from the last one. And we can see that the overall p-value is also the same as before. We may want to still investigate adding more variables to the model to see what happens. So you can also put in every single variable by including rating and then putting a dot to represent all the variables in the data set, which is equal to attitude, or you may actually type each of them one by one. Let's run this code. And as you can see, it has a similar effect as we had seen in the previous models. Complaints remains significant, and we have the coefficients with the ideas of unit increases and decreases for each of these variables and their impact on the rating variable. We also see that the multiple R-squared value has increased to 0.73. So it means that these combinations of variables explain 73% of the variation in that ratings variable. And there may be still some extraneous or outside factor that may be impacting the model. The p-value has also increased slightly, but it's still less than 0.05, which means that the model is significant overall, despite the fact that some of the variables themselves are not significant individually in the model. So this concludes the short tutorial. Feel free to continue practicing coding and understanding how the output is giving you a context to what exactly has happened in your data. Thank you.